All right, well, so with that, Ms. Michelle, if you come forward and introduce our guest.
Okay.
You get to watch a movie.
Yeah, y'all don't fall asleep.
All right.
Okay, my guest today is Mr. DeRouen. He's the president of 5D All-Field Magnetics and is a drilling engineer with 33 years of experience in drilling and completion of operations, project management, and executive experience. He has worked domestically and internationally. He started his career with Atlantic Richfield Company in 1980 and worked as a drilling and completion engineer. While working for Schlumberger, the team he assembled drilled the first successful offshore well drilled in the GOM.
Gulf of Mexico.
Okay. As a sidetrack with coiled tubing. Mark was also the Schlumberger and country operations manager for an Exxon Mobil project for 3 years in rotation in Chad, Africa. He started 5D Consulting, which specializes in coiled tubing drilling, and worked on a large North Texas CDD project for 2 years, drilling 45 horizontal wells. His latest venture includes the startup of a 5D all-field magnetic, which specializes in the application of magnetism in drilling, completion, and production operations. Mark holds one U.S. patent, which was the forerunner of today's brushes used in wellbore cleaning. The device he will talk about is open hole net, which is a patent pending. This is also my brother-in-law, for those of you who don't know, Mark DeRouen, and my sister-in-law is here also, Debbie DeRouen. So with that, Mark, it's all yours.
Thank you very much. I appreciate that. This is in the new world today, video, the young engineers, they love the video, they love the PowerPoint presentation on TV. Also, she was asking us, sometimes we put it up on the screen, but we spent a great deal of money on some very, very good animation. And a picture is worth 1,000 words. Okay? Very interactive, it's only 10 minutes here. Sometimes in the right engineering group, it'll go 3 hours, this presentation. Be careful what you ask me questions. Okay. Oh.
He needs to be, yeah, there you go.
Okay. The open hole net. The open hole net is an integral system of specially designed magnets that will be incorporated into standard rig bell nipples of any size to catch and hold metallic objects. Now, that's very important. We drop stuff in wellbores sometimes offshore, and cost, well, I was telling Michelle there, we had an incident that happened about 15 days ago that dropped a object in a offshore floating operation. This is, like I said, this is highly interactive. If you have a question, stop me. This is our animation that shows a little bit about how the unit works. What we're going to do right now is we're going to open the device up so we can check for metal. And that blue door that you see right there is where the metal would be stuck if it was dropped in the wellbore or if it was coming out of the wellbore, because we catch it going both ways. They both can impact the operation. And what we're going to do is we're just going to take it and come on the other side. And what we're showing our clients when we show this is that we have full access to the wellbore. In other words, we don't have to go down and do anything in the BOP. We can work right here and get to the problem. Okay. Now, I don't know if any of y'all know what a bell nipple really is. Okay, I don't know. I really don't. But basically, the pipe that we use to drill with runs through this all the time. It's going up and down all the time, okay? So, and we drop stuff through this hole. Believe it or not, you wouldn't believe some of the things that get dropped in the wellbore. I'll put a little pamphlet out, and if you can go on the website, which is a very short thing, you can read some of the stories about dropped objects, and some of them are just hilarious. We have to show them that it's easy and safe to operate, and that's why this video is shown like this. This is the unit that we just got delivered to us in Lafayette. This weighs 5,500 pounds. It's completely made of stainless steel. So Tom is closing the doors, and he's just showing how we lock them out and how he can, I mean, he's a very light guy. It's not hard to close them at all. Now, somebody's going to ask, well, wait a minute, what about magnetism and working close to magnetism? Magnetism is inherently safe, okay? It doesn't bother us. The only people that have to worry about magnetism are people that have implants, medical implants. pacemaker, defibrillator, things like that. But if it bothers you with a pacemaker, it does disrupt it, from what I understand. A defibrillator, all it does is basically turn it off when you step up close to the magnetism, and when you step away from the magnetism, it goes back on.
Can you check it, open the doors and check it any time? Or you gotta shut the rig down, or just...
Depends on the operation, but typically these doors can be opened and closed in 10 minutes to check, and that's not very much
You
time.
don't close the rig down to do that?
Well, depending upon what you do. If I'm conducting a certain operation, I might be able to close what we call the high drill and pump underneath it, and this would be open, and I could check it. Okay? And I could check it with pipe in the hole or pipe out of the hole. You see the little yellow pipe sticking out of the big column at the top? That's a simulated piece of 5-inch drill pipe. So here's our first tool that we had tested up in Michigan. And what we're going to do is this test right here is simulating a piece of drill pipe, a piece of 5-inch drill pipe running through the system with one of the magnet doors closed, and there's no fluid there. And we're going to catch these objects in air, which is a big deal. Wow. That's a BOP test bolt right there, weighs about 4.5 pounds. Three-pound sledgehammer with a wooden handle taken off. Now, what people don't understand is people drop objects in the World War that we just drill right through sometimes, because sometimes they're aluminum.
If aluminum or stainless steel, the magnet won't catch that.
No, but like an aluminum pipe wrench, it has a steel heel. The jaws are made of steel, so we'll catch it. And what we're trying to do is we're trying to show that if somebody did actually get mad like that and start chunking stuff in the World War, because people think it doesn't happen, but we get employees that are not happy sometimes too. And if we can't get them off the rig floor fast enough, this is what happens. And it still happens in the business. We'd go downstairs below the rig floor, open the door, and then we'd separate the magnet from the stripper door. There's 2 doors, and this is what we do. And one man's behind us, he's just separating the magnet from the stripper door. And this is how we clean it. Boom. Very simple, okay? This is the prototype. We're going to run through some of these dropped objects again, just to show you, because this is the true 16-inch model right here. Our clients want to see the test model, and then they want to see the real thing, so this is what we're doing right here. Same thing, same water with no viscosity. Water has basically 0 buoyancy, is the baseline, okay? An 18-inch wrench. And the thing about it is people don't understand that, people don't really understand magnetism at all. And right here, I could put that hammer and it would fall straight down, that close to the magnet. That's how we can focus the magnetic field. And that's what makes this so important, is bringing that science to this application.